You know, nano is a smaller size. The scaling unit is 10 power minus 19 per atom. Generally, it is the size of the atoms and molecules. The size of the atom is the 10 power minus 10 and the molecule is 10 power minus 14. So nano is higher than the little bit of the size of the atoms and molecules. So the nanotechnology is nothing but it is used to understand the phenomena from 1 to 100 nanometers. And also the properties are mostly depend upon the morphology. If you change the morphology of the material, the properties and the mechanical properties and the electrical properties are different for different kind of morphologies. Based on the morphologies, the nanomaterials are classified into zero cluster, one dimensional, two dimensional, three dimensional, and carbon nanotubes. So many types of nanomaterials will be classified into different categories. In addition, based on the crystallite size and the forms, we can classify the nanomaterials and nanocrystal, nanofilms, nanocomposite, nanopowder, quantum dot, nanocluster, nanotubes. So it can be classified into so many types. So these are some of the examples for the morphologies. So if you can prepare the nanotechnology in different morphologies, the properties will be different for the different morphology. For example, the star-like morphology will be very much useful for the biological applications. So the needle-like application will be sometimes used for water purification or something like that. So far the different morphologies will be reported in the literature. Nanotubes, nanorods, nanowires, nanocrystal, nanoshells. There's so many different morphologies were reported. So if you convert, this slide will show how the bulk material is converted into nanomaterial. What has happened? That slide will show this. When this is the bulk material, this is nanomaterial. So generally, if you convert the bulk to nanomaterial, here the energy gaps are continuous for the bulk material. If you convert it into nanomaterials, two things will happen. One, the energy gap is increased. Another one, the energy levels are discrete. So here the energy levels are continuous and the gap is very low. If you convert into nanomaterial, so you can get the wider band gap and the energy levels are discrete. So the nanomaterials are useful to get to tune the band gap. You can control the band gap by controlling the particle size. So this is one of the magnetic properties. We know about the bulk magnetic materials. Whenever the bulk materials, if you apply the field, it will comes to the uniform field. Once if you cut down the magnetic field, it will be goes to the random direction. That will be happened. But for the nano sample, it is different. So this is the bulk sample. Can you see the video, sir?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
It is a bulk sample. So if you apply the magnetic field, all the spin will be aligned in a uniform direction. Once if you cut down the magnetic field, again the spin will be comes to that random direction. That will be happen in a bulk material. Once if you break into nanomaterial, without any field, all the atoms will align in a uniform direction. There is no magnetic field is needed. So without magnetic field, all the spin will be arranged in a uniform direction. So that is the nano sample. So that is another advantage. That state is called a super paramagnetism state. So without any very less amount of magnetic field or without any magnetic field, all the spin will be aligned in a uniform directions. Another one is a surface to volume ratio will be increases. So this is the 1 centimeter cube. So the total surface area will be 6 centimeter square. If we convert it into 1 nanometer, that area will be around 60 lakhs. So that much surface area will be increases. If you convert it into 1 nanometer, that will be 1 millimeter. It is 60 cubes will come. So 60 centimeter square will come. So if you convert it into bulk to nano, the surface area will be increases. So that is a flow chart how the bulk material is converted into one. The same cube is converted into 8 cubes means the surface area will be 12. The same cube will be converted into 64 means that area will be 24. Again this it will be 48. There are the two methods will be available to prepare the nanomaterial. One is a top-down approach, another one is a bottom-up approach. Top-down approach means any bulk material can be converted into nano. Bottom-up approach means the atoms and molecules will be arranged to get the nano size. Actually, the bottom-up method means the atoms and the molecules are in smaller size, in the order of 10 power minus 10 or minus 12 and 14. So that atom will be put into nano size 10 power minus 9. Here it is around the millimeter and centimeter in 10 power minus 3 will be converted into here. So this is a schematical representation for the top down and bottom up methods. Here a bulk material is converted into a small nano piece. Here small atoms will be used to construct the nanomaterials. So it is adding by atoms or molecule by molecules. There are so many methods will be used for production of the nanomaterials. Lithography, milling, physical vapor deposition, so many methods are there. Among them, these methods are widely used. One is the ball mill method. Here, the bulk material is converted into nanomaterial by grinding. Another one is a sonochemical reaction method. The ultrasound will be used to disintegrate the bulk material to nanomaterial. Another one is a salt gel method. It is solution and then gel formation will be there. Laser vapor deposition. A laser light will be used to vaporize the atoms in the sample and it will be coated in the sample. Another one is a precipitation method. So nowadays there are the two problems will be there. One is energy and water. The solution will be there in the nanomaterials for both the cases. So one material I worked in my PhD duration. One is perovskite magnetic material. The chemical general formula for the perovskite magnetic material is AbO3. A and B are the different cations with the different charges and sizes. The general type and the general formula is CaTiO3 is a mineral. So that chemical formula will be same to this formula. So in this, what I did is I put some amount of A. Here LaMnO3 is a mode type insulator. La will be the 3 plus rare earth element. Mn will be 3 plus. O will be 2 minus into 3. It will be 6 minus. So here 3 plus 3 plus. It will comes to the neutral charge. So La 3 plus, Mn 3 plus. O3 is a 2 minus into 3. It will be 6 minus. That is a neutral. So where I replaced a small amount of rare earth element by a divalent, that is a trivalent rare earth by divalent. So wherever the rare earth is available, Mn will take the 3 plus. So La 3 plus, Mn 3 plus, O 6 minus, it will be neutral. Wherever the A is available, A is a 2 plus, divalent, it is a 2 plus, then Mn goes to 4 plus state. So 2 plus and 4 plus, again it is 6 minus, it will be neutral. So in this compound of divalent doping, the system goes to a mixer valent. It consists of both Mn3 plus and Mn4 plus. Mn3 plus will exist with La plus, Mn4 plus will exist along with the A. So in this, due to the divalent doping, it causes some complex phase diagram. So the different magnetic property can be explored by the composition of the A and the temperature as well as the pressure. So this property can be explained by the different theories of double exchange interaction theory. First theory is double exchange interaction theory. That is nothing but the interaction between Mn3 plus and 4 plus, that will be taken care of the account of explaining the magnetic property observed in a perovskite material. Another one is a John Teller. In this case, the Mn3 plus and Mn4 plus, that will be changes their state in multiple times. At the time, the structure will be discarded. That will be reasonable for the observed magnetic properties. Like that, so many explanations will be there. Another one is spinel ferrite materials. So Mn Fe2O4 is a general formula for the spinel ferrite material. Here M is a divalent element. There are so many applications are available for the spinel ferrites nowadays. Here in a spinel ferrites, the A site will be surrounded by some tetrahedral atom, and B site, yellow one is a B site, will be surrounded by the octahedral site. So the magnetic property of the material is only depend upon how the A atom and B atoms are surrounded by this two different sites. So generally the magnetic property of the octahedral site minus the tetrahedral site is the net magnetic property of this materials. If you change the state or by the defect of this octahedral site or tetrahedral site, one can modify the magnetic property of the material. In this case also I will introduce here some of the rare earth element. In general, the magnetic properties are only depends upon the FeFe interaction. Earlier there is no rare earth, so only FeFe interaction will be comes entered into the play. So that coupling is called as 3D electron coupling. If you introduce a rare earth, it will goes to 3D and 4F coupling, which leads to change the magnetic properties. So that is due to the rare earth and the Fe ions coupling. Another one I have worked after my PhD is SLR alloys. It is a family of alloys. So here the general formula is A2B3. A2B3 is a general formula. So it will be the 4 formula unit structure will be there for this. So this is a crystal structure for the SLR alloys. A and B are the different transition metal, where C is a semiconductor and non-metals. So using the semiconductor and non-metals, we are getting some extreme magnetic properties by using the true transition elements. These alloys have a L2-1 structure usually. So in the ferrites, I have studied the microwave absorption. Generally, the microwave absorption is nothing but it is a combination of conductive loss, dielectric loss, and magnetic loss. So this is a formula for the conducting loss. This is the formula for the dielectric loss. This is the magnetic loss. So we know sigma is a conductivity, epsilon naught, mu naught is the permittivity and permeability of the free space. Epsilon double dash and mu or double dash is the imaginary parts of the relative permittivity and permeability of the materials. Omega is the microwave frequencies. So in general, the absorption is depend upon this formula. SE. The specific absorption can be, shielding can be expressed in 10 log sigma AC divided by 16 omega epsilon naught mu double dash plus 20 into this term. This term is only depend upon the skin length. If you go with this term, SE is directly proportional to sigma E. Sigma E is nothing but omega epsilon naught epsilon double dash. And mu double dash is nothing but ms divided by 2HA by alpha. So if you increase the sigma by increasing the dielectric constant, if you increase the dielectric constant, sigma AC will increase, so the shielding property will increase. In another way, if you decrease the saturation magnetization of the magnetic material, mu double dash will be decreases. The mu double dash, if you decrease the mu double dash, again the sigma E will be decreases here. Increases here. If you decrease this term, it will increase. So that is the idea. In this idea, we have used, this is the schematical representation of the EM waves. So the electromagnetic wave has a beauty. Whenever the electric field is maximum, at the same time B is also a maximum. So when E is minimum, also B is also a minimum. So likewise, the E and B are the same magnitude, but the direction is different. So the doping element, first I have introduced some doping element. This is a copper Fe2 MnO3. In this material I have put some of the MnO. Instead of Fe I put some rare earth. So the band gap is little bit increased from 1.6 to 2.1. If you put some rare earth element, the band gap is little again increased 5.33. So the magnetic field also decreased. For this element, the magnetic field is little increased. However, for the dielectric constant, I have compromised with the magnetic properties. So in the same way, I used some different ratio of the lanthanide with this. So the band gap is little bit increased, but band gap is not a parameter for the microwave shielding example absorption. However, that higher dielectric constant is needed for the materials. The higher dielectric constant only depends on having the materials with have the high band gap. So this is a dielectric loss and dielectric constants. Here it is a magnetic field. So the magnetic field is decreased from here to here. It is 0.25. This is 1. The magnetic field is also decreased and the coercivity also decreased. So this is a graph for the micro absorption. So we have some absorption at the end of the expand. Generally the 8 to 12 is 8 to 12.5 is called as the expand. So we got some absorption at the expand. So this case, if I increase the lanthanum content, the band gap is increased, the dielectric constant is increased from 50 to 100, and the magnetization is decreased from 60 to 41. So this material is very much useful to microwave absorption. One is by increasing the dielectric constant, another one is decreasing the magnetization. So this is the same thing I have did with the radiation. The same material as prepared. By the magnetization, I have decreased the magnetic moment. This is a prepared sample. After this, I have put some radiation. Using the radiation, I have decreased some magnetization. So if the magnetization decreases, means the dielectric property may be increases, absorption properties. Another one I put on PVA. So in this compound I will put without PVA and with PVA. Without PVA, the dielectric constant is around 1400, it is close to 1800. So there is an increase in dielectric constant. Similar way, the magnetization is around 100 here, it is decreased around 80 here. So without polymer, it is around 1300, with the polymer it is increased. So the dielectric constant is increased. The similar way, the magnetization will be decreased from 94 to 84, here 42 to 41. So this is the reason how it is happened means PVA is a non-toxic and water soluble polymer. It has some strong forming ability with the high dielectric constant and optical properties due to the hydroxyl functional group available in PVA is attached with the lanthanides with some van der Waals forces. This interaction between the hydroxyl group and the rare earth will enhance the dielectric property of the materials. The same is also responsible for the decreasing in magnetization. The same way I have put it instead of neodymium, I put the lanthanum in this case. Here also sudden increase in the dielectric constant. It is 329, it is around 895. Here 780, it is the epsilon double dash will be 1875. Here also it is 1500, this is 1800. So there is an increasing in dielectric properties observed. So this is another work. The same material without graphene and with graphene. So the Fe sample, this is without graphene, the absorption is not at all a unique here. When I put the graphene along with this, so if you find out this sudden peaks, so the absorption will be increased due to the graphene modification. So the various combinations we can try. For example, ferrite plus reduced graphene, ferrite plus zinc oxide, ferrite plus ZnOC, ferrite plus WO3 and Pani, ferrite plus so many combinations you can do. So all these combinations you can find out this electromagnetic shielding properties. So I will list out some of the properties. So I already mentioned various morphologies were there. The properties can be modified based on the different morphologies. So this picture will be useful for the Women's Day. They will put the women can do the different role in different places. In the similar way, the nanoparticle can play the different role in different places. So the same titanium oxide will be used as antioxidant. Sometimes it will be used to increase the color reflector, and it's also sometimes it will be increase the mechanical strength. So likewise, the nanosilver will be useful for the different kind of applications. So in the washing machine nowadays, it will be coated with some nano product in order to avoid the corrosion. So the Nippon paints, they will get some antibacterial as well as the anti-reflection coating using due to the zinc, not nano zirconia particles and also nano zinc particles, ZNO. So this is one of the application of Bucky papers. This paper is one of the advantage of the nanotechnology. This is a smaller paper, but it is 500 times stronger than the steel when it is a composite. It like dissipate the heat. It can conduct electricity like a copper. It is a fire retardant. It can be used to grow the biological tissues. It can be eliminate the computer and the television screen. So it's a light paper, but the strength is 500 times stronger than the steel. So this is a Bucky paper. It is very smaller when compared to this. This can be obtained by 50,000 times smaller than the human hair. It consists of carbon atoms. That carbon atoms are very smaller than the very smaller in the nano size atoms. Another one, nowadays everyone will like a pink color, especially the girls like a pink color everywhere. So if you increase the particle size, you will get the different pink color. The 30 nanometer will give this kind of pink color, whereas the 90 nanometer will comes this pink color. So if you increase the color or the particle size, you can get the different kind of pink color. So that will be used along with the fabrics. So nowadays fire retardant properties are there. If you change the morphology, you can get some properties like this. This kind of textile material will be useful nowadays. In a table mat, they will put like this. So water won't be react. This is only depends upon the morphology. So the same thing is available in the two-wheelers. So you can. So this is depends upon the morphology. This kind of properties. It is a water repellent. So the water repellent properties can be obtained by the different morphologies. And also the material in nowadays the textile material will be coated with a different kind of material like TiO2 or zirconia or any kind. The fire retardant properties can be even increased by zirconia as well as the silica also. So you can't wash your dress even if you is coated with the nanomaterial, means the dust won't be affect the dress. So whatever may be there, it won't be affected. The color won't change. Even the water can't react. So some of the advantages will be there. So even that MIT will be used for this kind of musical jacket. Whenever you are feel some stress, so the piezoelectric crystal embedded with the jacket will sense your heartbeats and it will give some input to you. You are feel little bit hot now. You feel little bit tense now. Like that, the instruction will comes to us. So that kind of jackets will be available. Even if you get tense larger, it will automatically switch on this music. So it will play some music. So even the fire retardant material for those people who are working in fires related work, so they need some of the material like fire bullet proof. So that is also possible with coated with the nanomaterials. Another one, the antibacterial cosmetic applications also nowadays will be prepared by our traditional helper, but the traditional herbal will be converted into nanomaterial. That will be useful. For example, this is the chili powder. If you take the chili powder in a bulk form, if you apply it in a face, means you will get some irritation. It will be not useful. The same chili powder is converted into fine nano powder. Then if you apply it in your face, means it won't affect you. So that way, the herbal that be converted into nanomaterial, then will be applied on a face. So that is a before and after. You can change some different. The commercially available one of the nanomaterial is the powder. Face powder is a nanomaterial. You can feel the difference. How if you apply the without powder and with powder, your face can be little bit changed. So that is also another example for the commercially available. So nowadays the gold facial is everywhere. It's available nowadays. If you go for a natural or any kind of shops for a haircut, they will ask, sir, do some gold facial, sir. Your face will be suitable for a gold facial. But they won't use the gold. They will use only the zinc oxide. The zinc oxide in a bulk form is a white color. If you convert the same zinc oxide in a nano form, it will come under the gold color. That will be used for your facial applications. So the gold facial is not a gold, it is a zinc oxide facial usually. Nowadays, if you see this kind of product, if you taken out the backside of this product, how the nanometal will be incorporated. Even the Vico, you can find out some of the TiO2, what is the content is available. And the zinc oxide, in all the face items, you can find out some of the zinc oxides. So that I already mentioned that thing. Chili powder. The only problem is you can't use this both in a same time. Cosmetics in the natural as well as allopathy in the same time means your face will be affected a little bit. So what happened? You know the gold in yellow color. If you convert the same gold in nano means it will be either the white color to some pink color. So it depends upon the color. So if you convert into nano scale, it will be very much change the color. In civil engineering also so many applications will be there. I have some of the arts that you can build your house nearby the railway track. Even in the railway track also you can build your house. That is only possible by incorporating the nanosilica particle or TiO2 particle along with the cement. So nowadays the people will increase the mechanical strength by adding the nanoparticle with the cement. Another one is water purification. It's the simplest way of water purification is the carbon nanotubes. So it is easiest way. The carbon nanotubes will be mixed with the dirty water. If you put one magnet here, so all the dust in the water will be interacted with the carbon nanotubes and it will be attracted towards the magnet. So you will get a pure water within 2 to 3 minutes. After 2 to 3 minutes, you will get some pure water. This is the way. So if you put it in a bottom way, it will settle a little bit time. So this is the way. So this product will be developed by our atomic energy. So the carbon nanotubes will be used to enhance the strength and stiffness and improve the durability, increase the functionality and reduce the flammability. So the carbon nanotubes is directly mixed with some of the cement. So another one is self-cleaning and self-controlling the transparent glasses. So some of the dust will be easily cleaned. This is due to the morphology of the glass plate. And the paints also nowadays it mixed with some of the compounds of nanotechnology. You can control the antimicrobial self-cleaning surfaces and sensor pressure, heat, light, every can that they can detect the paints nowadays. Okay, uh, this is the bulk emulsion. This is the nano emulsion. You can find out how the particle will be dissolved in this. In the nano emulsion, you will get some uniform distribution of colors. For example, the bulk, it won't be uniformly distributed. Even it is larger time also, it won't be takes a uniform color. Another one you can this one, the water repellent property, the same way the paint will be control the water repellent. Whatever may be the water will be put on the car, it will fall down. So the same technology will be used in the paint. This I have already mentioned. This is a brick developed in our lab. It is a low thermal expansion and high density, higher alkali resistance and improved lifetime, higher density. This brick has been incorporated with the nano TiO2 at a 5%, incorporated with the silica brick. So reduction in thermal expansion will be there due to this compound. One can produce some of this. So in this is a hot plate. In this hot plate, one side of the plate is covered by nano emulsion coating. Another side will be empty. So here the temperature is 168. Here the temperature is 192. So there is a huge difference in the temperature. If you put ice here, it is melted easily. If you put it ice here, it won't melt, it can withstand for some time because the temperature is reduced here. So you can change the temperature. In electronic industry also nowadays, the flexible electronics will be useful. Even that you can build your chips in the hand. So that flexible electronic devices are available. Once if you bend it, you can find out the circuit diagrams. So these materials will be very much useful for this AlO2, alumina, zirconia, titania and FeO3. Generally AlO2, alumina will be useful for catalytic and bone cement. ZrO2 is useful for the dental care and other applications and fire retardant, surface coating, textile. Many of the applications will be useful for the ZrO2, zirconia. And TiO2 will be the solar cell, antimicrobial. This kind of properties are depend upon the TiO2. And the energy storage and battery application is mostly depends upon Fe2, Fe TiO3. It is similar to the perovskite type materials. So nowadays, so many companies are using the nano products for their white teeth. So if you see this things, if you compare with your active lemon, salt and everything, will be gives the good but everything will be depend upon only the nanomaterial, not by everything. It's either the silicon oxide or zirconia or nano HAP or nano silver. Depend upon the content they are used only, it will give the color. Nowadays, the people used to fill the cavity using the composite. Earlier, the gold, the big man will put a gold, and the normal man they will use the silver, like that. But the composite gives a uniform thing. You can get the same color like this. There is no change in the color. If you put a gold, that will color will be different. The composite will give the same color. Cavity filled, here the cavity is there. It will be the same color. So these materials will be useful for our root canal treatments. So this kind of materials will be used. This is also a titanium, zirconia, and lithium based bases. So once if you want to teeth is broken, so the metal will be inserted here, and they will put some screw and they will add another teeth. Like this, they will put some teeth for you, artificial teeth. So you can't find the difference between the real and the artificial one. So that is the advantage of the composite material. Another one material is a shape memory alloy. Shape memory alloy is nothing but that can retrain its original shape after the energy treatment. So this is the parent site, arsenide site. If you deform it, either cooling or it will go to some another state. Again, the molten site will be converted into arsenide by using the heat or the cooling. So instead of this, you can see this, you can easily identify this. So this is one of the spring. So the spring state will be stressed or elongate. Anything you can do, you can fold it and screw it, everything you can do. So after that, if you put a small amount of heat on the sample, it will comes to the original state. So this kind of material will regain its original shape by applying either the small amount of heat. So the aerospace applications are depend upon this kind of alloys nowadays. This is called shape memory alloy. They can regain its shape. Another one, the nano ceramics are nowadays very much useful. Like a ferrite material will be coated on the back side of the material. Like you can use that same as a ceramic materials. So it is doing the experiment is very easy, but the cleaning is very different. Like a magnetic stirrer, it is difficult to clean, but this are put with the magnetic ceramic tiles. You can easily clean. There is no much effect is needed. So it won't affect any of the instrument part. You can easily clean the heating the plate and everything. So it is a ceramic, so it won't be work. Even some of the tiles also possible by the magnetic ceramic. The back side of the tiles will be coated with some magnetic material. Whenever if you need, you can take out the tiles, you can put it in another place. So the back side of this one is coated with some magnetic materials. You can change your tiles from hall to bedroom and bedroom to halls, like that you can change. These sites are also useful for recording this magnetic structure. Another one important material is a biomaterial. Biomaterial will be useful for our day-to-day life activities. Someone's met accident, we can put some plate, that is called as a biomaterial. Biomaterial means it can be easily attached with any bio bodies. So that called as a biomaterials. It is non-visible material. is a medical device intended to interact with the biological system. It is used to make the device to replace any part of the function and body in a safe, reliable, economical, and physically acceptable manner. In any of the substance, the natural or synthetic, so many biomaterials are available nowadays. So this is the water and doctors. They will put some of the nano devices to cure the viruses in the body. You can attract the viruses like that. They will put some nano machines. It will be kill our things. So like that, so many applications will be there. For a lens, that is also a nano material that will be coated with some nano material. So that is useful for the multifocal. Nowadays, if you go for a eye surgery, the doctor will suggest a multifocal lens. The multifocal lens is possible only by the nanomaterials coated lens only. So these some of the examples for the biomaterials. So if the hip is broken, they will put the artificial hip is here. Something, if you put something in a leg, so they can be scratch can be removed. So these are the some of the biomaterial. They have the excellent electrical and mechanical properties, and it has high melting point. It has a higher mechanical strength than compared to our bone. And artificial skin is also available in nowadays. So once if you got some scrap, you can put some artificial skin on this. So in this outlet, I can conclude that the nanotechnology is a powerful tool for the modern world. The properties may be different from the bulk material. I already mentioned that you can change the property of the material by converting it to nano size, as well as by changing the morphologies. If you change the morphologies, the different is the properties is different. And one of the things, the safety is a biggest issue for the nanotechnology nowadays. We have to take care about the safety measures. Thank you. And then I have to mention this two opportunities is available for our Indian nation. One is IITB. It's available in IIC Bangalore as well as the IIT Mumbai for this characterization of your nanomaterial. As well as some of the facilities are available for UGC, DAE, CSR. There you can do your characterization for the research scholar, especially if you find out any difficulties in characterization, you can approach the IIC and IITB or either UGC, DSR, CSR labs. They can easy to help you to characterize your samples. Thank you. Any questions?
Thank you, Dr. Shakti. It was actually a wonderful session.
Yes, sir.
All the concepts were well explained by beautiful videos too. So now the session is open for discussion. I request the participants to ask questions. I request especially students to ask questions to Dr. Shakti. If you have any doubts, please clarify. And I think some questions are in the chat box.
Yes, sir. I will find out the chat box question. Someone is asked raise a hand, sir, I think.
Chedana, I couldn't see this chat box. Can you please read the question?
Sir, no questions have been shared here, sir.
Okay. Dr. Shakti, can you comment on the future aspect of this nanotechnology?
I already mentioned, sir, everywhere the people are working in nanotechnology. If you take out a small example, a car, some people are working on a mirrors. The glass should be a water repellent and it should be very thin. Some people are working on paints on a car. Some people are working on a low weight material for fabricating the devices. Someone is working for nano ACs. So someone is working for fuel along with the some nanoparticles. For example, alumina particles. Some people are trying, I think so. Along with this, they are also increasing the efficiency of the petrol. So everyone is working. For example, the tube. The tube is also the tire. Tire is also coated with some nanomaterials and alloy wheels. The alloy wheels also based on the nanomaterials only. So the people are working in different ways to bring out some useful applications for the nanotechnology.
Okay, one question is there in the chat box, and there's a question from Asha Srinivasan. And the question is, how stable are the zirconia nanocomposites in medical applications?
Nowadays, I already mentioned the zirconia has a variety of applications. Many of the biological materials are based on only on zirconia only. So it is highly stable material. Zirconia is. In addition to that, the implant material, for example, that paste you are putting in a teeth to fill the cavity is also a zirconia.
Okay, I think there are no further questions. No questions are there in the chat box.
Thank you, sir.
So if there are no further questions, I take this opportunity to thank. Oh, sorry, one more question is there. That question is from Lovely Chetan. Which method is used by you for the synthesis of nanoparticles?
Yes, I will go and explain. Some time is free there, so I will go and explain this slide now. Actually, I skipped that slide. Due to the time constraint, I will skip that slide. Now I will explain the slide. So there are the different methods are available for synthesizing the nanomaterial. Ball mill is nothing but a similar method like a grinder. Here the sample and zirconia balls will be put in a container. So the balls will be fitted with this sample, it will be converted into nano. So in between the salt, the bulk salt will be converted into nanomaterials by in between these balls. So this is easily, you can find out here the salt will be broken into a nanomaterial. So this is the way of ball milling. Another one is I used in the lab is a sonochemical reactor. Here I will use this ultrasonic horn. This is the sample. So I will use that sonicator. So the high intense ultrasound will be produced from the horn. It will be passed through the sample. That will be used to break the materials in the liquid. Another one is the sol gel method. Here it is modified one. So here you can find out how the surface area will be increases automatically. This is another sol gel method. So generally the magnetic particles may be prepared by the sol gel method, but any method has some limitation based on the particle size. If you go for a sonication, the particle size is around 40 to 60 nanometer. You can't get beyond this. For example, the ball mill technique is useful for the bulk synthesis, but there also the particle size is little limited. Around 60 nanometer only you can get from the ball mill. And also the laser vapor deposition is the easiest method. High intense laser will be targeted on the samples and the sample will be evaporated and it will goes to the substrate. So that is the laser, pulsar laser deposition. So the laser light will be here. So it is high intense laser, so it will vaporize some of the samples here. So that atom will go here and it will be put in a substrate. So that is the pulsar laser deposition. Another one is a precipitation method. Many chemists know about this method. You can put some precipitation. You will put some of the chemicals to precipitate the samples. So we put some of the chemicals that can be easily converted into solution. Yes, we can come back.
Okay, Dr. Shakti, some more questions are in the chat box.
Yes, sir.
One question is from Sandu Labid. What about nanomaterials in super hydrophobic coatings?
Sir, just a minute, sir. I will open the chat box. Which question, sir? I think what is the tax? The tax will be there, but we have to taken care about there. Another one question is what is super hypo coating? That is depend upon the particle size. Again, the morphology. If you control the morphology, then you can get the hydrophobic, either hydrophilic. That can be depends on only the morphology. You can take the same material, the different particle size with the different morphologies. You can control this kind of property.
Okay.
What method is ferrite material? Ferrite material you can synthesize a sol gel method. It is the easiest method for a laboratory level.
And one question is from Conain M. Do the nanoparticles that are used for implantations produces ROs inside the body or release some sort of toxic substance within? And how and why does the body not attack these nanoparticles as foreign substances?
Yes, it should interact with some RAS. They are exactly mentioned in the question, but it should be. We have to study before that implant. There is some of the procedure will be there. The clinical trials will be there. Some of the things we have to take in care in the animal house. So after that only the people will go for implant. Sometimes for a same material will be coated on outside of the material to increase the mechanical strength sometimes. But the bioglasses are another advantage one. So some people are working in nanobioactive glasses. So that is also an interesting subject area now. So bioactive glasses can be converted into bioceramics when you implanted in the body. So that kind of work is also.
I think the time is 11:45 and there are no further questions, I think. So I take this opportunity. Yes, sir.
Sir, 1 second, sir.
Yeah.
Sir, one more question has been missed, sir. By Shankrama K. Which method you chose for synthesis of ferrite composite and why? Why zirconium nanocomposites is used for medical field?
Yes, I answered that question. That sol gel method is the easiest method to synthesize the ferrite particles. If you the facility is available, you can go for a sonochemical reactor also. But easiest method you can useful for the ferrite. The video which I shown is only the ferrites only.
Sorry to interrupt. Can I ask a question?
Yeah, yes, of course.
Yeah, this is Dr. Shankrama K, Assistant Professor JSSIR, being a nanotechnologist. Whatever the video you saw, sir, that is actually autocombustion method. So my understanding, if it is wrong, please mention it here. Yeah. And I asked the question, why zirconium nanocomposites are used for medical field? So stability as well as the synthesis method, I hope I understand why you choose zirconium nanoparticle. And one more question I asked, sorry, that which method you choose for ferrite nanocomposite? Because I'm exposed about the ferrite nanocomposite during my research. That's what I ask.
Actually, the ferrite composite, I preferred using the sol gel method, madam. I have that facility, so I used that sonochemical reaction method.
Yeah, sir. One more point. Actually, sonochemical method is not only easy method. There are number of methods are there. Based on the methods, we can synthesize particle. So, in my point, I hope autocombustion method is good for the based on the applications, particularly ferrites.
There is another advantage is there. You can control the morphology. You can change the morphology.
Exactly. Yeah,
So,
yeah. Nice
basic
presentation, sir.
applications, it will be useful.
Yeah, yes. Thank you, sir. Thank you so much.
And zirconia are used only due to the mechanical properties. Like if you consider the mechanical property, zirconia will be better when compared to silica.
Yeah, sir. Thank you. Thank you so much.
Okay, if there are no further questions, I would like to thank Dr. Shakti for his wonderful lecture on the
Thank you, sir.
analysis in nanotechnology. Okay, thank you, sir. Thank you so much.
Thank you, sir. Thank you.
Over to Chedana.
Thank you, sir. Thank you for the informative session, sir. I also thank Dr. Midin Dominic, sir, for chairing the session. Thank you, sir. Now we will move on to the second session. The talk will be delivered by Dr. Burcu Saygıder Demirman, Professor, Kukurova University, Turkey. This session is chaired by Dr. Basapasar, Professor and Chairman, DOS in Organic Chemistry, University of Mysore, Mysore. He has been felicitated with many awards, which includes National Merit Scholarship 1992 to 1999 from Government of India, Sir C.V. Raman Young Scientist Award 2012, and many more. He has published around 99 papers in reputed national and international journals and owns the ownership of 8 patents. Under his guidance, 6 research scholars have been awarded PhD till now, and he has been awarded with many fellowship awards. I heartily welcome you to this program, sir. Now I request you to chair the session.
Thank you. Thank you, Madam. So, at first, I thank Professor Mallu sir, who gave me an opportunity to chair this session. And at first, I welcome impressive in relation with medicinal chemistry. So she obtained her undergraduate and MSc and PhD and related MSc in psychology also from Turkey University. University of at the Adana, Turkey. So University Institute of Natural and Applied Sciences. So she presently working as a postdoctoral researcher at Sidezer Lab, Sukurova University, Central Research Laboratory, so which is situated at Adana, Turkey. So her area is really impressive. So as I mentioned, so she works with translational medicine and including drug discovery, pharmaceutical chemistry, and she has trained as a cell culture scientist and molecular. She studied molecular biology and she knows about bioinformatics and in silico trained person. So so in addition, she thesis title is examination of metal phosphine complexes and their cytotoxicity towards an antioxidant enzyme called antioxidant enzyme activity. She studied. She shown the pharmacological using so many cancer cells, including lung cancer cells. So with this good biodata, so I do request Burku Madam from Turkey to enlighten our two days virtual conference in nanomaterial and related even medicinal chemistry. So I welcome you, Madam, now.
Yes, madam, you are visible. You are audible.
Am I audible?
Yes, sir.
Yes. Thank you, sir. Hello?
Yes, madam, you are audible.
Hello.
You can talk it.
Okay. Hello? Dear participants.
Hello.
Hello. My sound
Yeah.
is here? Okay. Hello,
Hi.
participants. Okay. I'm from Çukurova University in Adana, Turkey. This is
Thank you. Please. You take. Yeah. You go for your presentation, madam.
Okay.
We are
This is
listening.
Okay. This is my university. It's a wonderful university. Yes. Today, in this conference, I will talk about metal complexes used in cancer treatment, their mechanism of action, and some of our studies on this subject. As we know, inorganic elements have an important place in the human organism. They are used as building blocks in the regulation of some processes and as cofactor of enzymes. Carbon, oxygen, hydrogen, nitrogen, phosphorus from the structure of DNA. Calcium, magnesium, fluoride is the building block of bones and teeth. Sodium, potassium stabilize blood pressure. Iron participates in the structure of hemoglobin, and some others are used in cofactors, essential elements. Interestingly, inorganic compounds are also used in the treatment of some diseases. Actually, metals have been used in the treatments since ancient times. The first use of metal compounds in medicine was for tuberculosis, treatment with potassium cyanoaurate. Followed.
Hello, ma'am. Sorry for interruption.
Okay.
Ma'am, slides are not moving, ma'am. Like, please give slide share, ma'am.
Yes.
Ma'am, give slide share, ma'am. Slideshow.
Is this okay? Is this okay?
Madam, please, can you give the full screen?
It is full screen
That
already.
Or F5, you can give F5. The fourth icon is the bottom, madam.
Can't you see it? I done full screen already.
Yes, madam. Now it is moving.
That's a problem, I think.
You share once again, madam. No problem.
Okay. Can you see it?
Yes, we can see the presentation.
Okay. Is it changed?
Please change for the next slide, madam.
Yes.
No,
I'm
it is
changing
not.
now.
No, it is not changing here.
There's a problem. I did full screen.
I think so now we are visible with the first slide, the title slide.
I clicked full
Yes,
section.
now we are. It is getting on. You can continue.
Can you see like that?
We can see the slide moving.
Yes, okay. Okay. I will present like this type. Okay. Where the first use of metals in medicine was tuberculosis, I said, with potassium dithionurate. And then sodium guanidate were used in treatment of rheumatoid arthritis since the early 20th century. These are some examples of metal complexes which used in medicine. For example, copper and manganese complexes used in anti-inflammatory, and lithium carbonate used in manic depressive psychosis. And some vanadium complexes, mimetics of insulin for anti-diabetic. And antimicrobial agents, some palladium complexes and antimony complexes, and antiparasitic complexes there are gold 1, gold 3, and ruthenium-based antiparasitic agents, we can say. And anti-ulcerative agents, bismuth and iron complexes, and antihypertensive complexes, these are. Metal, it is known that gold compounds are used in the treatment of rheumatoid arthritis, and zinc complexes are used in healing of wounds, and silver compounds are used in prevention infections and burns, and tungsten polyoxyions are used in the treatment of AIDS. Where is it? Yes. Metal ions or compounds are also used for diagnostic in medicine. For example, technetium is the most commonly used radioisotope agent for imaging purposes. It has a short half-life, emits only gamma ray photons, and does not emit beta or alpha particles, and thus is particularly suitable as an imaging radioisotope. The other examples, gadolinium-3, iron-3, manganese-2, are paramagnetic metals, produced contrast images for MRI imaging. Another example is cobalt-3. It is used with the compound belomycin, which is an antibiotic, to be selectively to be taken up by tumor cells, but its half-life is too long to be conducted for imaging purposes. Why metal complexes? Comparison to organic-based ligands, metal complexes have more advantage. For example, coordination numbers, geometries, oxidation reduction states. Firstly, metal complexes targeting DNA. DNA has been primary target. Metal complexes, due to the ability of cationic metal interacting with the anionic backbone, phosphate backbone of DNA. The anti-cancer chemotherapy drug, cisplatin, as we know, covalently bind to DNA, which disrupts transition and leads to programmed cell death, which we called apoptosis. Metal complexes targeting also enzymes and proteins. Metal complexes can interact with the amino acids with the highest reduction potential. For example, histidine, cysteine, and selenocysteine. Let's see. Transition metals are member elements of D block, as we know, and are included in group 3 and 12 of the periodic table. They possess unique properties. For example, charge variation. In aqueous solution, metal ions exist as positively charged species. Depending on this existing coordination environment, the charge can be modified to generate species that can be cationic, anionic, or neutral. Most importantly, they form positively charged ion in aqueous solution that can bind to negatively charged biological molecule. The other one, structure and binding. Relative to organic molecules, metal complexes can aggregate to a wide range of coordination geometries that give them unique shapes. The bond length, bond angle, and coordination site vary depending on the metal and its oxidation state. In addition to this, metal-based complexes can be structurally modified to a variety of distinct molecular species that confer a wide spectrum of coordination numbers and geometries, as well as kinetic properties that cannot be realized by conventional carbon-based compounds. The other one is metal-ligand interaction. Different forms of metal-ligand interaction exist. However, these interactions usually lead to the formation of complexes that are uniform, those of individual ligands or metals. The thermodynamic and kinetic properties of metal-ligand interactions influence ligand exchange reactions. The ability of metals to undergo this reaction offer a wide range of advantages to metals to interact and coordinate with biological molecules. The other one is Lewis acid properties. Characterized by high electron affinity, most metal ions can easily polarize groups that are coordinated to them, thus facilitating their hydrolysis. Partial filled D shell for transition metals, the variable number of electrons in D shells or F shells influenced the electronic and magnetic properties of transition metal complexes. And the last one, redox activity. Many transition metals have a tendency to undergo oxidation and reduction reactions. The oxidation state of these metals is an important consideration in design of the coordination compound. In biological redox catalysis, metal ions often serve to activate coordinated substrates and to participate in redox active sites for charge accumulation. Let's come to the cancer. Cancer cells are not different cells. They are our own cells. Normally, our cells commit suicide in a programmed way after a certain number of divisions. The things that make up this suicide mechanism are the signaling pathway in the cell and the abnormalities that occur during the processing of proteins, for example, phosphorylation, methylation. In this pathway, disrupt the suicide mechanism of the cells, causing the cell's proliferation rate to precede the destruction rate. And tumor tissue occurs in the area where it is located. All of these are the results of DNA mutations caused by some environmental factors, for example, UV rays, chemicals, etc. These are effects or genetically transmitted, maybe. There are cells in which one or more irreversible mutations have occurred in their DNA for various reasons. These mutated cells are cancer stem cells, and if one day a drug can target these cells, we will have won our battle against cancer. These mutated cells proliferate by mitosis and form the tumor tissue. If the cells cannot obtain enough energy, in this issue they are in and remain without oxygen. The cells first migrate to the blood and then to another suitable tissue, and they began to multiply there, which we call metastasis. There are two types of death mechanisms. One is necrosis and the other is apoptosis. No matter what you give a cell in high doses, it will go into necrosis, but it can have fatal results. But apoptosis means programmed cell death. If the cell suicide mechanism is broken, apoptosis means to push it to commit suicide again. If the wrong functioning of proteins or enzymes in apoptosis signaling pathways can be changed, the agent that does this is a good anti-cancer agent. Many metal compounds, especially transition metal complexes, kill cancer cells by various mechanisms. For example, membrane depolarization, arrest cell cycle, or DNA adducts, ROS production, protein bindings and inhibition, endoplasmic reticulum stress, and finally, the cell's death. What you see is the first cancer drug cisplatin and its derivatives. The discovery of cisplatin in the 1960s represented a landmark achievement and ushered in a new era in cancer treatment. Despite the fact that cisplatin has achieved significant clinical benefit for several types of solid tumors, such as ovarian, head and neck cancer, bladder, cervical, melanoma, lung, and lymphomas, its effectiveness has been hampered by toxic side effects and tumor-resistant that often leads to occurrence of secondary malignancies. However, discovery and use of cisplatin have encouraged investigators to search for and develop novel non-platinum containing metal species with superior anti-cancer activity and low side effects. Cisplatin binds to DNA, causes a change in the three-dimensional structure and leads to that of cancerous cells. Organometallic compounds interact with DNA in three ways. One is building with the major grooves in the structure of the DNA. The second is the binding with minor grooves. And the third is the intercalative binding. The organic background of the drug and the type of metal, a coordination step also, affect the type of chemical bond that the drug will make. For example, different types of bonding, such as electrostatic interactions, covalent bond, hydrogen bonds, can be observed. And also, sometimes metal complexes can mimic the substrates of enzymes or another protein to bind to protein, thereby inhibiting some proteins achieving cancer. These are some examples. There are many drug candidates discovered for cancer treatment in the literature. For example, PAK1 inhibitor. This is ruthenium complexes. And the other GSK3 inhibitor, this is ruthenium complexes again. Rhodium complexes inhibit state 3 proteins. All these proteins expression high in cancer cells, and we want to inhibit this. The metal complexes do this. These are another examples. In the table, we can see which type of compounds are effective in which cancer, by which mechanism, and which dose we can increase such examples. What is important is the discovery of cancer cell-specific targeted drugs with fewer side effects. We want this. For example, GOLD1, GOLD3 complexes, induction of apoptosis, inhibition of TRXR enzyme, which increase in cancers, and these ones, IC50 range. IC50 range, a little, that's a good drug for us. The other examples, for example, caffeine-derived rhodium complexes, inhibition of TRXR, and the cell lines, these codes, cancer cell lines codes, kill these cancers, I think. Yes. We increase the examples. I will pass. Yes. Metal-based nanoparticles. Mr. Pandey mentioned before. Metal-based nanoparticles are structures that come in different shapes and sizes and have potential for use in diagnosis and therapy. The most commonly found metal-based nanoparticles include nickel, gold, silver, iron oxide, gadolinium, and titanium dioxide. Metal-based nanoparticles provide a large surface area that allows loading of high doses of drug. Various high specific and high sensitivity nanoparticles-based optical imaging platforms are being investigated to increase specificity in cancer diagnosis. Nanoparticles can be processed to specifically target tumor cells. Nanoparticle can be multifunctional and exhibit optical, magnetic, and different structural properties in a single molecule. Specific targeting can be achieved by conjugating the surface of nanoparticles with a molecule or biomarker capable of binding to the tumor cell receptors. Yes, it is an example therapy, interesting therapy. Sorry. Boron neutron capture therapy. This is a therapy modality wherein a boron-10 containing compound is administered to selectively accumulate in the cancerous tissues, followed by irradiation of the tissue with neutrons. The boron-10 nuclei capture neutrons and undergo a nuclear reaction, emitting alpha particles and lithium nuclei, both of which deposit the kinetic energy that carry within an extremely short distance the size of a single cell. Boron neutron capture is attractive for the treatment of well-localized, not too deep-seated tumors, as it is possible to deliver huge amount of energy precisely within the tumor without causing damage to the surrounding healthy tissues. Brain tumors such as glioblastoma and skin cancers have shown promising results with BNCT. The currently used boron compound is an amino acid derivatives, para-boronophenylalanine, which has one boron atom per molecule of BPA. Unfortunately, this is not adequate for efficient therapy. Hence, designing a suitable compound with an adequate number of boron-10 atoms, delivering it preciously at the tumor site, and having a neutron beam that is amenable to use in clinical setting, constitute a major challenge in the growth of BNCT. Search continues on the discovery of new boron-containing molecules for BNCT. Yes. Now, I will briefly tell you about all the studies we have done in our laboratories. This is my PhD thesis work. We synthesized water-soluble metal complexes, and we examined its anti-cancer in lung and leukemia cells. We synthesized palladium, ruthenium, and platinum complexes. These are phosphine complexes. We aim to inhibit some enzymes with increased activity in cancer cells. In the cytotoxicity tests, the lowest IC50 value indicates the best activity. The IC50 value is the drug concentration at which half of the cells die. We revealed that the platinum complex has both the best cytotoxic effects and the best inhibition of some increased enzyme, especially in leukemia cells. The other study. In this study, published in 2020, two different chip-based nickel complexes were synthesized and their anti-cancer activity was examined, collaboration with Iran. These are two nickel complexes we synthesized. It has been demonstrated that both complexes have better cytotoxic effects compared to cisplatin. Cisplatin versus complex 2 and cisplatin versus complex 1. The black one is cisplatin, the red one are complexes. It's better cytotoxic effect. At the same time, it was seen in induced cell death both in time-dependent and dose-dependent manner by apoptotic pathway. These are flow cytometry results. As we can see, this area show us apoptotic cells. Right diagrams. Yes. At the same time, it was seen induced, yes, cell dose-dependent and time-dependent manner, 24 hours and 48 hours, we can see. Increase the apoptotic cells. The other study, this is a study we have done with hydrazone ligands. We also compared with Iran corporate. Hydrazone ligands are highly preferred ligands in the fight against cancer, which can easily interact with DNA due to their flexibility and many other superior properties. These are new nickel complexes with hydrazone ligands. The anti-cancer activity of this novel nickel hydrazone complexes was investigated, and they were found to be quite effective in A549 lung cancer cells. The IC50 values is very low, especially the complex 1. Yes. DMSO, what is DMSO? DMSO, the solvent of the complexes, was used as a control. Complex 1 induced apoptosis at different times and doses compared to the control. Ultimately, both complexes induced apoptosis at high dose. But we want the low dose inhibition, and complex 1 like to this. This is, the left one is scratch assay, or the other one, the other name is wound healing assay. First, for this, first we plant cancer cells on plates with a diameter of 3 centimeters. When the cells cover the entire area, we slit the cells with a pipette tip. The name of this wound healing. This gives us the opportunity to understand the effect of drugs on cell migration, that is on metastasis. We want to drug administered cells to have stopped this progression, while the control cells were advancing into the opening after 24 hours. In this study, both complexes reduced the rate of metastasis. This result was confirmed by examining the expression levels of some genes that are effective in metastasis. Vimentin cadherin snail ZEV1. This study is a newly published study that we have done with mercury and manganese complexes of nicotinohydrazone ligands. After synthesis of ligands and its metal complexes in Iran, the anti-cancer activity of the ligand and its three different metal complexes were evaluated. While the ligand was not active, different IC50 values were observed in three different complexes. The most notable result was the selective anti-cancer activity of mercury complexes 1 and 2 in HUH cell lines, HUH7 cell lines. These are flow cytometry experiments results again. The apoptotic rates of complexes revealed that 1 and 2 successfully drove the cells to apoptotic process in comparison to complex 3. As we can see, the red ones is apoptotic cells and the upper in it. Yes. The other experiment, PCR experiment. Complex 2 significantly increased P21 and P53 gene expression in both cell lines. This is evidence of induction of apoptosis, we can say. This is colony formation assay. Was performed on 2 hepatocellular cancer cell lines, and it was revealed that 3 metal complexes stop cell colonization at different dose. This is DMSO as a control. 24 hours later, you can see the dots of cells, colony of cells, and the complexes, we cannot see any other colonies. When the showed that these complexes are transported in the cells by binding to serum albumin. Gradual addition of complexes to bovine serum albumin leads to an increase of the intensity of the absorption band at 2018 nanometers, supported by a blue shift of about 7 nanometers or 1.4 nanometer for 2 and 5 nanometer for complex 3. These results show that complex change the polarity of microenvironments around the tryptophan and tyrosine amino acids of BSA. The change in the absorption band of BSA in the presence of complex indicates that the complex BSA interaction is in the form of static quenching. In addition, we have proven the binding of these drugs to DNA, and we determined the type of binding they to do with DNA. Absorption spectroscopy monitored titration is a powerful tool to probe the way metal complexes bind with DNA. Any interaction between complex and DNA is expected to disrupt the ligand center spectral transition of the complex. Interaction of small molecules with DNA often results in the redshift and hyperchromism. In case of groove binding or electrostatic attraction between small molecules and DNA, there may be little or no redshift, which reflects conformational chains and hyperchromism. The UV visible spectra of complexes 1, 2, and 3 contain an absorption band 293, 287, and 292 nanometers, respectively, 1, 2, and 3. Hyperchromic effects were observed upon gradual addition of CT-Kif-Thymus DNA to complex 1 and 2. However, no redshift was observed, indicating that complexes 1 and 2 interacted with ctDNA via groove binding and or electrostatic interaction rather than the intercalative mode. Hypochromism was observed in the UV visible spectrum of complex 3 in the presence of ctDNA, indicating intercalation characteristic. This, yes. After this, the binding constant was determined by kinetic calculations and compared with the literature and splitting. It was observed that these 3 new complexes made very strong bindings. These are the references. This is my team in Çukurova University, Adana, Turkey. We are working like this type of studies. In future studies, we plan to first perform computer-based scans for targeted drug delivery, then synthesis and in vitro and in vivo drug research. We have collaborations on drug synthesis in Turkey, Iran, Russia. We have a team related to animal experiments at Koç University in Istanbul. Researchers who made in silico analysis were also added to our team, Kartik. And now we are writing a project on nanodrug development with physicists, researchers at the university we are in. And we have started our work. Thank you to all our team and Kartik. And I would like to thank you, dear participants, as well. And thanks for inviting me.
Thank you, ma'am, for the presentation. I also thank Basappa sir for chairing the session. Now we'll take a break and be back by 1:30 for the next session. Thank you. You can leave the questions in the